Okay, two more solution strategies, the dominance and social welfare. Let's talk about first about dominant. So an agent can have a dominant strategy. That's what we call it. Basically, in this example here, look at Bob. So you call it dominant strategy. So basically, that means that the agent wants to take that action regardless of what the other guy does. Right? So in the case of Bob here, Bob says, well, if I take C, I will get either 3 or 2. If I take D, 1 or 1. So, 3 is bigger than 2. 2 is bigger than 1. So clearly I should take C. Right? So C dominates D. Now if you had, we only have 2 actions. But if you have multiple actions, you might have that, this strategy dominates another strategy. So any strategy that is dominated by somebody else, we can say it's never going to get played, right? Because you will never play this. You would play this one instead. You will never play D. Bob will never play D. He will play C instead. So that's a dominant strategy. And what we do with iterated dominance is we just look at that and we say, well, Bob clearly is not going to take D, so let's get rid of all that. So I'm going to ignore all that part of the tree. The game matrix. Bye-bye. And so now we just have this game matrix right here. And agent A has 2 actions, either A or B. And okay, so let's say, for example, that this was a 2 here. So this strategy B now dominates A. So A can then say, okay, that dominates that, so goodbye. And so the solution via iterated dominance is 2 or B, C, right? So that's iterated dominance. The problem is, it's very logical. It makes perfect sense that your dominant strategy is what you want to take, right? So an agent is never really going to want to not take his dominant strategy. The problem is that he might not have one. So let's put some numbers back in here. Put the numbers for Bob. So 2, 1, and 2, 1. Right. So now if you look at that, Bob no longer has a dominant strategy. So okay, so here's D. So if he plays C, he's going to get 1 or 2, or D, 2 or 1. Well, none of them is dominant, right? So 1 is less than 2, but 2 is greater than 1. So, and this is much more common, right? So you will have a lot of game matrices where there is no dominant strategy, or even if there is, maybe you can get rid of 1, but that's it. So it's basically it's a great first step to get rid of dominated strategies, but that doesn't get you to a solution. The other solution is the social welfare solution, and the social welfare solution has a very simple form. Simply, let's call it S star. It is simply, as an equal sign, the arg max over all. This is all possible strategies. The sum of everybody's utility for that particular S. So overall agent I's. So it is the set of strategies. So here S is a vector of strategies, right? Like, AC for this case. So try all possible strategies. The one that maximizes the sum of everybody's utility, that's the one. So when you look at the normal form game, all you have to do is look at each box, add up the numbers in each box. So here would be 2, 4, 4, 4, and 4. Again, so now we have a tie. So we have these 3 strategies are social welfare solutions, right? Because they're all worth 4, and that's the sum of everybody's payments. If, let's say this wasn't a 3 here, let's break the tie. Let's say this was a 4 here, so then the sum is now 5. Now, this is the social welfare strategy. BD, right? So that would be our winner, the social welfare strategy. So you maximize the sum of everybody's payoff. So it sort of, it tries to capture the idea of social welfare, like, welfare for everybody. But you see, it's not that great, like in this example. yeah, we're maximizing the sum of everybody's, but Bob is getting 1. You know, he could have gotten 2 over here, right? But he's getting 1. It's not so good. While he's getting 4. So it doesn't seem fair. It can be very, very unfair. Just to maximize the sum of everybody's payoff can result, you know, in one guy getting, you know, 1,000,000 and the other guy getting 1. And that box, because this number is so large, that's the one we're going to choose because that maximizes the sum. 1,001 in this case. So social welfare always exists, of course, and you know there could be ties. It's easy to calculate, and always could be ties, and but it can be unfair or unstable. Like in this case, if we say this is the case, we're gonna be B and D. Bob might look at that and say like, okay, B and D, I don't like that. I'm gonna play C. If he's gonna play B, I'm gonna play C. That way I can get 2. So it's also unstable, right? You see, we can't just, if we play BD, Bob says he's gonna think, okay, if Alice is playing B, clearly I should play C because then I can get 2. So dominance and social welfare, 2 more solutions.